Based of the question 1, we are given the density function of density x square plus y square. So since the shape of the region is circular, so it is easier to switch to polar coordinates. So in polar coordinates, we change the expression x square plus y square to becomes r square, and the area element dA becomes r dr d theta. So the density function becomes pr square. And the limits of integration for r goes from k to 2, and for theta goes from 0 to pi over 2, because it is only for the first quadrant. So now we set up the mesh integral using the polar coordinate. We include the data and the function into the formula. We integrate and we got the answer. Mesh is equal to density pi 4 minus k the power of 4 over 8.
Now I will explain the solution for question 1 part 2, which is to find the center of mass of a metal sheet. We begin with the formula for center of mass in 2 dimensions. So we need to change in polar coordinates, which is x equals to r cos theta and y equals to r sin theta. Then the area element dA in polar form is r dr d theta. So the integral for x becomes x equal to 1 per m integrate of r cos theta pr power of 2 r dr d theta. Then solve the integrals, and we got 32 minus k the power of 5 per 5. 8 for r integral. Then for theta integral we got 1. So x equal to p per m times 32 minus k power of 5 per 5. Then we substitute the value of m, which were found in part 1. So the answer for x is 8 times 32 minus k power of 5 per 5 pi times 16 minus k power of 4. Because the region is symmetric in the first quadrant, the x and y coordinates of the center of mass are equals. So the answer is x equal to y equal to 8 minus 32 minus k power of 5 per 5 pi times 16 minus k the power of 4.
Okay, so for question number 2 for this assignment, given RT is equal to in bracket 3 cos t, 3 sin t and 2t, with the range given that is t is larger or the same with 0 and t is smaller or the same with 2 pi. So for question A, the geometric path is 3 cos t and 3 sin t is equal to x, which is the circular motion in the x and y plane. And for the 2t, which is z, it is linearly increasing across the graph. For question B, for velocity and acceleration, finding velocity is equal to r prime t, which is the derivation of rt. The answer is in bracket negative 3 sin 3, 3 cos t and 2, which is the derivation from the given question. And for acceleration, the acceleration is equal to r prime prime t, which is the derivation from velocity. So negative 3 sine 3. Derive we got negative 3 cos t. 3 cos t. Derive we got negative 3 sine t. And from the number of 2, if we derive, it will become 0. And for the question C, which is speed, modulus v prime t is equal to sed negative 3 sin t square plus 3 cos t square plus 2 square, and the summation is equal to sed 9 plus 4, which is equal to sed 13. And for question D, which is the total distance, the distance is equal to integration from 0 to 2 pi, integrating v prime t dt, which is the answer for speed. So when we integrate from 0 to 2 pi for sed 13, we get sed 13 times by 2 pi, which is 2 pi sed 13.
For part E, unit tangent, normal vector and curvature. First, unit tangent. Tt is equal to v prime t over magnitude of v prime t equals to 1 over sed 13. For the vector unit is negative 3 sin t, 3 cos t and 2. Then take the derivative of dt. dt over dt is equals to 1 over sed 13, and the vector is negative 3 cos t, negative 3 sin t and 0. Now the unit normal vector n prime t. dt over dt over magnitude of dt over dt, and equals to negative 3 cos t, negative 3 sin t, 0 over t. And the answer is negative 3 cos t, negative 3 sin 3, negative sin t and 0. And the last one, curvature k. Magnitude of t prime t over v prime t, magnitude of v prime t is equal to 3 over sed 13 over sed 13, and the answer is 3 over 13.